Hi, welcome back to my channel Math Caffeine. This is the start of a new series, Relationships with Triangles. There are quite a few theorems to know for this series, so let's get started. The first theorem is called the perpendicular bisector theorem. It explains that in a plane, if a point lies on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. If you look at this image, point C lies on the perpendicular bisector line CP. Then the distance from point A to point C is the same distance as point B to point C. The perpendicular bisector also has a converse, which states that in a plane, if a point is equidistant from the endpoints of a segment, then it lies on the perpendicular bisector of the segment. In this example, if the length of segment AC is the same as the length of segment BC, then point C must lie on the perpendicular bisector of the segment AB. Theorem 6.3 is the angle bisector theorem, which also has a converse theorem. This one says that if a point lies on the bisector of an angle, then it is equidistant from the two sides of the angle. For example, if point D lies on the angle bisector of angle BAC, then the length of segment BD and CD are equal and perpendicular to the two rays of the angle. This is the converse of the angle bisector theorem, which states that if a point is in the interior of an angle and is equidistant from the two sides of the angle, then it lies on the bisector of that angle. For example, if point D lies on the inside of angle BAC and is the same distance from both of the rays, ray AB and ray AC, then it lies on the angle bisector, ray AD. Theorem 6.5 is the circumcenter theorem. It states that the circumcenter of a triangle is equidistant from the vertices of the triangle. In this image, we draw perpendicular bisectors from the triangle to find the circumcenter labeled in these blue lines here. The red lines are all congruent. The circumcenter is the spot where all the red lines drawn from vertices A, B, and C meet. They are all congruent. The incenter theorem describes how to find the incenter of a triangle and what it implies. The incenter of a triangle is equidistant from the sides of the triangle. You draw the blue lines, which divide each angle in half, and those lines meet at a point called the incenter. When the lines are drawn perpendicularly to the sides, they are all the same length. Theorem 6.7 describes where to find the centroid of the triangle. If you draw a line from each vertex to the midpoint of the side opposite to the vertex, they would meet at the centroid. The centroid is 2/3 away from each vertex to the midpoint of the opposite side. In this example, segment CD starts at vertex C and ends at the midpoint of segment AB, and so on for the other lines. All three lines meet at a point G. BG is 2/3 of segment BF, AG is 2/3 of segment AE, and CG is 2/3 of segment CD. The triangle midsegment theorem states that the segment connecting the midpoints of two sides of a triangle is parallel to the third side and is half as long as that side. In this example, segment DE connects the midpoints of segment AB and CB. It is parallel to side AC and is half the length of segment AC. The triangle longer side theorem states that if one side of the triangle is longer than another side, then the angle opposite of the longer side is larger than the angle opposite the shorter side. For example, if segment AB is some value x, and segment BC is some value x plus some value n, as long as n is greater than 0, then we know that angle A, which is opposite of segment BC, is larger than angle C, the angle opposite of segment AB. This theorem is called the triangle larger angle theorem and is similar to the last. If we know that one angle of a triangle is larger than another angle, then the side opposite the larger angle is longer than the side opposite of the smaller angle. For example, if we know that angle C is some value x, and angle A is some value x plus n as long as n is greater than 0, then the side opposite of angle A, segment BC, must be larger than segment AB, the side opposite of angle C. The triangle inequality theorem states that the sum of the lengths of any two sides of a triangle is greater than the length of the third side. For example, we know that if we add side A to side B, then its length will be greater than side C. The same goes if we add side B to side C, we know that it will be greater than side A. Lastly, if we add side A to side C, we know that its length will be longer than side B. The hinge theorem compares two triangles using two sides and one angle. It also has a converse theorem. This one states that if two sides of one triangle are congruent to two sides of another triangle, and the included angle of the first is larger than the included angle of the second, then the third side of the first is longer than the third side of the second. In this image, if segment AB and segment DE are congruent, segment AC and segment FD are congruent, and we know that angle A is equal to 43 degrees and angle D is equal to 86 degrees, we can conclude that side FE must be longer than side BC. This is the converse of the hinge theorem. If two sides of one triangle are congruent to the two sides of another triangle, and the third side of the first is longer than the third side of the second, then the included angle of the first is larger than the included angle of the second. For example, if we know that segment FE is 10 feet and segment BC is 7 feet, and we know that segment AB is congruent to segment DE and segment AC is congruent to segment DF, then we know that angle D is larger than angle A. If you have any comments, questions, or concerns, feel free to email me at mathcaffeine@gmail.com. Hope this helps. Happy studying!